So hi guys, today I'm going to tackle about the summary of chapter 6 network layer. So network application and services on one end devices can communicate with application and service running on another end device. So the protocol of the OSI model network layer specify addressing and processes the enable transport layer that enable the transport layer data to be packaged and transported. So the network layer encapsulations enable to be passed on destination within a network with a minimum of overhead. So let's go. I'm going to proceed. So the network layer uses four basic processes, which is the addressing and devices, encapsulation, routing, and the encapsulation. So the addressing end devices. So end devices must be configured with a unique IP address for the identification of the network on the network. So and in encapsulations, the network layer encapsulates the protocol data unit or the PDU from the transport layer into the packet. So the encapsulation process adds IP header information such as the IP address of the source and the destination. So the source is the sending and the destination is the receiving. So destination host. And for the routing, um, the network layer provides services to direct packet to a destination host on another network. So to travel other networks, the packet must processed by a packet. The so must process. So the router of the route. So the rule of the router is to select the best path and direct packet towards the destination host on in a process known routing. So the encapsulation. So when packet arrives at the network layer of the destination host, the host check the IP address within the header match in its own IP address. So the IP address is removed from the packet. So there are only two network layer protocols that are commonly implemented. So it is the Internet Protocol version 4 or the IPv4 and the Internet Protocol version 6 or the IPv6. So these two are the only network layer protocol that are commonly implemented. So for the next one, so the characteristic of the IP. So characteristic of the IP, it has the connectionless, best effort, and the media independent. So so in the connectionless, it is no connection with the destination. It is established before sending data packets, and best effort. IP is inherent unreliable because packet delivery is not guaranteed. So for the best effort, it's not guaranteed. And then media independent. So operation is independent of the medium carrying the data. So the medium is the copper, fiber optic, and the wireless. So the IP connectionless going. So I do a brief explanation about the connectionless, but it also connectionless, but I'm not gonna explain. But this is the so for the IP connectionless, this one, the sender doesn't know for the so connectionless communication. So for the sender doesn't know if there is so that doesn't the because connectionless. So the sender doesn't know if the receiver is present, if the letter arrived, if the receiver can read the letter, and and for the receiver, the receiver doesn't know when it's coming. So for the next one, the IP best effort delivery. So IP best effort delivery. So as an unreliable network layer protocol, so IP does not guarantee that all your packets will be received. So other protocol manage the process of tracking packets and ensuring the delivery. So unreliable means that IP does not have the capability to manage and recover the undelivered or corrupt packets. So for the media independent, so for media independent, so IP packet can travel over different media. So yeah, the IP packet can travel over different media. So for the next one, we have significant fields in the IPv4 header includes, so we have, so the version, the differentiated service of depth serve, time to time, protocol, source IP address, destination source IPv4 address, and the destination IPv4 address. So on the version contains a 4-bit binary value set to 0100 that identifies as an IP version for packet. So the differentiated services or DIFServ or the DS, formally called the type of service or the DOS field. The DS field is an 8-bit field used to determine the priority of each packet. So the six most significant bits of the DIFServ fields is the differentiate service code point or the DSCP, and the last two bits are the explicit congestion notification or the ECN bits. So for time to time TLV, so it contains and for 8-bit binary value that used to limit the lifetime of a packet. So for the protocol, so field is used to identify the next level protocol. So this 8-bit protocol value indicates that the data payload the type that the packet is carrying, so which enables the network layer to pass the data to the appropriate upper layer protocol. So common values include the ICMP1 or TCP6 and the UDP 17. So for the source IPv4 address, it contains 32-bit binary value that represent the source IPv4 address of the packet. So the source IPv4 address is always a unicast address. So source is always a unicast address. So destination IPv4 address. So it contains a 32-bit binary value that represent the destination IPv4 addresses of the packet. So the destination IPv4 address is unicast, multicast, or broadcast. It can either the destination IPv4 address can either a unicast, multicast, or broadcast. For the next one, so yeah, the most common reference field are the source and destination IP address. So IPv4 still has the three major issues, which is the IP address depletion and the internet routing table expansion and the lack of end-to-end connectivity. So so the but let's go back to this one. So the IP address depletion. So IPv so IPv4 has a limited number of unique public IPv4 addresses available. Although there are the approximately 4 billion IPv4 addresses, the increasing number of new IP-enabled device always on connection, and the potential growth of less developed regions have increased the needs for addresses. So for the internet routing table expansion, a routing table is used by router to make best path determinations. So for the lack of end-to-end connectivity, the address translation or the NAT is a technology commonly implemented with the IPv4 network. The NAT provides a way to multiple devices to share a single public IPv4 addresses. So for this one, the improvements that IPv6 provides include, so it has the increased address space, improved packet handling, eliminates the needs for NAT. So for the increased address space, so the IPv6 addresses are based on 128-bit hierarchical addressing as opposed to IPv4 with 32 bits. For the improved packet handling, this IPv6 header has been simplified with a fewer fields, and eliminates the need for the NAT. With such a large number of public IPv6 addresses, NAT between the private IPv4 address and the public IPv4 is not needed. So this avoids some of the NAT includes application problems experienced by the application requiring end-to-end connectivity. So one of the major design improvements of IPv6 over IPv4 is simplified IPv6 header. So another rule of the network layer is to direct packet between host and between hosts. A host can send a packet to itself, local host, and remote host. So itself, a host can ping itself by sending a packet to special IPv4 address or the 127.0.0.1, which is referred to a loop interface. So ping the loopback interface test the TCP or IP protocol stacks on the host. So for the local host, this is a host on the same local network as the sending host, and the hosts share the same network address. So the remote host, this is a host on a remote network, so the hosts do not share the same network address. So default gateway. So the default gateway is the network device that can route traffic to other networks. So it is a router that can route traffic out of the local network. So if you use the analogy that a network is like a room, then the default gateway is like a doorway. So if you want to get the another room or network, you need to find the doorway. So so the routing table of a router can store information about directly connected routes, remote routes, and the default routes. So directly connected routes. So these routes come from the active router interface. So routers add a directly connected route when the interface is configured in an IP address and is activated. So each of the routers interface is connected to a different network segment. So remote routes. So these routes came from remote networks connected to other routers. So routes to this network can be manually configured or on the local router by the network administrator or dynamically configured by enabling the local router to exchange routing information with other routers using dynamic routing protocol. So default route, like a host, router also use a default route as a last resort if there's no other route. So there's no other route to desired network in the routing table. So So this is the Cisco Integrator service routers. So this the picture. So Cisco routers are designed to address the needs of many different types of businesses and networks. So there's our branch one service provider. So the branch, teleworker, small business, and minimum size branch site. So it includes Cisco integrated services router, so or G2 or the second generation. And for the one or wide area network, so large businesses, organization, enterprises includes the Cisco Catalyst series switches and the Cisco aggregation services routers. For the service provider, so large service provider includes a Cisco ASR, Cisco CRS, and 3-carrier routing system and 7600 routers is series router. Um, then Cisco router uses 4 types of memory, which is the RAM, ROM, and NVRAM and flash. So the RAM, it is a volatile memory used in Cisco router to store application processes and data needed to be executed by the CPU. For the ROM, this is non-volatile um, volatile. So memory, it's used for, so the RAM is volatile and the ROM is none. So it is used to store crucial operation instruction and the limited iOS. So NVRAM or NVRAM is non-volatile unlike the RAM. So it is used as permanent storage for the startup configuration file or the startup config. So the flash, it's non-volatile also. It volatile computer memory used as permanent storage for the iOS and other system-related files such as log files, voice configuration files, HTML files, backup configuration, and more. So similar to Cisco Switch, there are several ways to access user exec mode. In the CLI environment on the Cisco router, so these are the most common. So the console, secure, shell, and telnet. So I already tackled that on chapter 2. So as I said, I already tackled that on chapter 2 summary, I think, or chapter 3. So yeah. So thank you for watching, guys. I hope you learn in chapter 6 summary. And again, thank you for watching.